All right, so this lesson that I need to teach you today is about derivatives of inverse functions. But I don't want to jump in without a really fast review about functions and their inverses. So this little worksheet, you don't need to write this down. I literally just want you to follow along and make sure you understand. And if you don't, please come in and ask. Okay, and I'm going to try to highlight what I'm looking at any particular time. Okay, so let's take a look at this problem in yellow. This is saying for this function over here, when you plug in -1 into that function, which is here, what is the function value, right? Which means you go up and figure out where that lines up on the y-axis. That's why that answer is 4. Okay, now let's take a look at another one. Okay, so let's say now that we are looking at the next problem down, which is here, okay, in baby blue. So this is a different question, okay, and that's why notation is so important. It's saying if, that is not the color I want. Here we go. If -1 is the output, right? Here, -1 was the input. But now, because of this notation, -1 is the output. That's down here. It's asking what was the input. So that is the x value, which is why this answer is 1. Okay, so then similarly on this next problem, this is saying, hey, if 3 is the input, 1, 2, 3, what is the output? That's why this answer is 1. But more important, okay, much more important is this one. If 3 is the output, right? Which, and again, it's the output because of this notation. So let's take a look at 3. 1, 2, 3. So I'm looking at all the places where the y value is 3, and that's why there's 3 answers. -1, -1/2, and, sorry, not that one, right there, 5. Okay, so now let's take a look at the tables, okay, because there's some function composition going on here, and you have to be able to do a couple different things. So let's focus our attention on, and in fact, not even number 1. Let's jump to number 2. Okay, I'm going to look at number 2. This is saying if 5 was the output of the f function. In fact, I'm looking right here. 5 is the output. What was the input? So this problem now becomes g of 3. Which is why the answer is 2. All right, again, you have to understand inputs versus outputs and what the notation means. Let me erase and let's do number 5. Again, I didn't want to do all of these, but I did want you to look at some stuff. Okay, so let's take a look at number 5. I'm going to focus my attention here inside the parentheses. Okay, so this is saying if 10 was the output of the g function, which is here, what was the input, which is 2. So let me rewrite this. And then this new problem is saying, okay, well, if 2 was the output of the f function, what was the input? That's why it's 9. All right, so with that all being said, let's jump into this lesson. Okay, so let's take a look at this function that is already pre-drawn for you, okay, which is, again, this little curvy line. So that's the function, and this is just some random ordered pair right here on the function. I'm going to call that location AB. Okay, and I want you to recognize that if I said, hey, what is f of 5, the answer to that would be 7. When you put a into the function, b comes out. All right, and then this notation up here is saying what is the slope of the function at 5. The slope when x equals 5 is 2. Okay, in other words, it would be sort of the rise over the run, 2 over 1. Okay, and again, all of that, none of that is new. Okay, that should all sort of be in your head already. Okay, now I'm going to switch colors, and we're going to try to draw the inverse of this function in. Okay, and I'm going to do this in a different color. The inverse reflects over this line. This line is y equals x. Okay, so if I'm trying to mirror it over that line, hopefully you can see that it would look something like that. Okay, again, not the best drawing in the world, but it's a mirror. And the notation here would be the inverse of f. Okay, and there would be an ordered pair over here that it would be a reflection of AB, and it would be 7, 5, which is BA. And just like on the function on the other side, I can say that f inverse of 7 would produce an answer of 5. When you plug in B into the inverse, A comes out. Okay, but here's where things get really, really interesting. The slope of this line, okay, the slope of this line is 1/2. This slope on this side was 2, but the slope of this line is 1/2. But let me make sure that I have some notation here for you. So the inverse at 7 derivative would equal 1/2. So the connection I need you to make here is that when I have the inverse of a function and I take the derivative, it is equal to 1 over the derivative at the output number. Okay, so let's fill in this chart, okay? Because again, this is probably the 80 millionth time you've heard me say the word notation. But this notation and this notation are important. So on this chart, the point was 5, 7, and the slope at 5 was 2. But the inverse has a completely different ordered pair. It's reversed. And the inverse derivative, and again, I'm just showing you a different notation here, at 7 is equal to 1/2. Okay, so I'm going to fill in this rounded rectangle. Let's see how this looks. Okay, if the inverse derivative of b is equal to 1 over the derivative of the inverse of b, where the inverse of b is equal to a. All right, let's see what we can do on this with the chart and the table and everything. Okay, so this can be a little confusing. So I want to see if I can help you out here. So the first thing I'm noticing is that we are not talking about regular inputs and outputs because of that notation. Okay, so this 4 is not an input. It's considered an output, which means that the input of the f function over here is 2. So let me just write that down as x equals 2. So what is the derivative when x equals 2? Well, the derivative when x equals 2 is 6, which means this answer up here is 1/6. Okay, so try that again on this next one. Like, try that on your own. Pause the video, see if you can figure it out. So this is how my thought process works. This is the output. Okay, so I'm looking here in this column again. I'm looking for an output of -2. There it is. That means my input was 0. So what is the derivative when x is 0? That's over here. It's 5, which means this answer up here is 1/5. All right, so for this problem, this is an easy one. If it says what is f of 4, you're going to plug 4 in for those x's. So 1/4 times 64 plus 4 minus 1, which becomes 16 plus 4 minus 1, which is 19. So when you put 4 in, 19 comes out. Input, output. Okay, this is asking us to do the derivative. In fact, I'm going to switch colors. This is asking us to do the derivative. Here we go. The derivative of that original function is 3/4 x squared plus 1. And when I put 4 in there, that's 3/4 times 16 plus 1, which is what? 12 plus 1. So f prime of 4 is 13. Okay, so now the question becomes, for what value of x can we easily find the derivative of g? Okay, and notice up here, g is equivalent to the inverse. Okay, you do not have to find the inverse function. We should be able to answer this automatically. And here's how you do it. If this was the input and this was the output, I should be able to find the derivative of the inverse when x is 19. I'm looking at the output. And I know what it's going to equal. It's going to equal the reciprocal of this number, which is 1/13. So g prime of 19 should equal 1/13.